the early 1970s, there is a hunger within the scientific community to know more about the 4 outer planets that dominate our solar system: Jupiter, Saturn, Uranus, and Neptune. If more can be understood about these gas giants, it could unlock secrets to the history and formation of our Earth and the solar system.
Exploring the solar system in which we live enables us to understand more about how our own Earth was formed.
To understand our position in the evolution of the solar system, let alone the galaxy, we needed to get out there beyond the asteroid belt and really get to grips with what those planets were about. That was Voyager.
NASA does not have the luxury of time on their side. This plan to explore the deepest, darkest, and most inhospitable regions of our solar system must take advantage of a favorable alignment of the 4 outer planets that would not occur again until the 22nd century.
The Voyager program, the Voyager missions that would allow the spacecraft to fly by planets and use the gravitational energy of the flyby to increase the velocity of the spacecraft and change the trajectory, change the direction in which the spacecraft was moving in order to encounter another planet. So it was almost like a game of planetary billiards.
This favorable planetary alignment would occur in the late 1970s and allow NASA to harness gravitational assistance to slingshot the 2 Voyager probes from one planet to the next. Exploiting gravity in this way not only reduces the need to carry large quantities of fuel, but also has a huge impact on the mission timeline.
Without the gravitational flybys that this alignment made possible, it would have taken 30 years for the Voyagers to reach Neptune instead of 12 years, which was ultimately possible.
Launched a few weeks apart in the summer of 1997, the twin probes of Voyager 1 and Voyager 2 set sail for their one-way tour through our solar system. After 18 months, the Voyager spacecraft arrived at Jupiter in 1979.
The Voyager program really transformed our view of the solar system, and at Jupiter, Voyager showed us the first ever active volcanism at a place other than the Earth, with Jupiter's innermost moon Io, and they were found to be the signature of an enormous volcanic plume rising from the surface of this extremely turbulent moon of Jupiter. It's really one of the landmark discoveries. The dynamics of the famous Great Red Spot, this enormous storm that has a size equivalent to that of the Earth, was studied in great detail. The Saturn encounter was arguably the most photogenic of the Voyager program. One of the most famous discoveries that Voyager made at Saturn was the existence of what are known as shepherd moons. In the outer ring system of Saturn, there are 2 very small moons which were moving on either side of these rings, and these became known as the shepherd moons because the gravitational influence of those moons actually shepherds those particles into a stable orbit and makes the existence of these rings possible.
At this point, the Voyager probes part company to follow very different trajectories, with Voyager 1 heading to Saturn's largest moon.
Titan is a very interesting moon. It's a very enigmatic moon. It was known from ground-based observations that this largest moon of Saturn had an atmosphere which was very rich in methane, and methane is of great interest in terms of the ability of a moon or a planet to sustain life. But a consequence of that was that the trajectory would take the Voyager 1 spacecraft out of the plane in which the planets move, and therefore Voyager 1 would not be able to encounter Uranus and Neptune.
However, Voyager 2 continues on its mission towards Uranus and Neptune.
The real star of the Uranus encounter was that the planet has quite a significant magnetic field. And the structure of this magnetic field is very unusual. It has a corkscrew shape, something that isn't seen in any of the other planets. And this is one of the most important discoveries of Voyager in terms of the planet itself.
Voyager 2 has its final planetary encounter with Neptune in 1989, the outermost of the gas giants, and the most distant planet in our solar system.
Neptune came as a complete surprise.